hand everything over to Art, who needs no introduction because Art has given us so many great presentations here. He's Mr. Microgrid, should I say? and he has a wonderful example in his home of how he heats and gives energy away. I mean, he's just a nice guy to live next door to.
I have one neighbor.
Anyway, Art, if you would like to introduce your fellow panelists. Thank you.
Okay. We have only one microphone, so we'll be, we've agreed to sit and make our presentations and use the pointer as best we can. Clearly, the climate emergency is multifaceted, and we have for this presentation focused in on buildings and the energy footprint. I'm not saying carbon footprint intentionally, because my facility's there and I don't have a carbon footprint, but I sure can reduce my energy footprint. There are three of us, and I will be going first, and I am the owner-operator of the Manotick Microgrid. I'm also on your board of directors and your webmaster. Jane Wilson is an architect who also is from the Manotick area, and she's an owner-operator of what she calls her 21st century home. The difference between her and I is I operate a very active energy flow establishment, and she operates one which is quite passive, and she controls the energy once it's within the building envelope. And Sucha Mann is He's run the sustainability portion of the Professional Engineers of Ontario, the Ottawa chapter, and he is also a lecturer at Carleton University. He's going to be telling us about some of the good work that's going on in Carleton and some of the associated people that they work with. I'm going to I almost got up and let you sleep. I'm going to handle this myself. Just quickly, here is what my house looks like, and there's solar on top and a bunch of extra panels on the side. Over here, I call this the geothermal wall, which itself would take about an hour to explain. This is the control room, where everything happens, and there's displays and many things that people can see when they visit. This is the ground element going in. As you can see, it's a coil, and it went into a trench, and I'm drawing energy from the ground. And this guy is a quick looking at energy profiles, and I'll be talking a little bit about that, but each one of those can take half an hour in their own right to explain. I say this is Ottawa's first fossil fuel-free home, a lot of F's. Sustainability without fossil fuel, so every time you see a little check, that means that it's been verified. I have given 126 tours of my facility, and each time I give a tour, I increment this and I update the presentation, because clearly the questions that come mean I haven't done my job and told them everything that they need to know at the beginning, so I try and fix it for the next round. But the whole purpose was to demonstrate 100% electrification and getting that electrification from renewable sources. Now, the objectives are, and I got to lever them here, I'm going to burn through them: near seamless elimination of power from the electricity grid, no gasoline, and no natural gas. That, of course, has been verified and done for over a year now. Use of the grid for backup power and sales only, done. provide energy security, including survival support. We're right now on day 95 of being off-grid, or what that really means, I am not drawing power from the grid for 95 days. I'm shooting for 100 days, and that's going to happen on the same day as our election. I wish I was smart enough to have planned that, but that just happened. The other most important one, and what we're going to be addressing mainly today, is find and optimize energy efficiencies. I've done a number and got at the low-hanging fruit, as it were, and there's much more to do in phase 2. I do provide performance demonstrations, and of course, any evidence that I put forward, it's all measured. It is, as a scientist, I can't say anything unless I can back it up with hard data. I want to lead by example and, of course, motivate others, which means I'm pretty open source and share solutions and techniques. The only thing I will honor are any non-disclosure agreements I have with any of my industrial partners. Seventh, I want to reduce harm during this unfolding tragedy. That's a major motivation. I want to prepare for grid and internet isolation during these disruptions, and of course, cyber attacks are always a threat. I certainly want to prove we're not locked into this suicidal capitalism. There is a way out. And of course, move speculation into fact-based discovery and have an innovative laboratory which, in fact, will continue to grow, and with new systems being added over time. I also want to demonstrate what I call good neighbor, and this is energy sharing during any major outages. I have 4 main thrusts which are driving my design and of course demonstration. They're happening simultaneously. I plucked this off the internet, so none of these words are mine. Survival, of course, is a major concern, and I like this better than dead. But in fact, to meet basic needs in a survival mode, that's constantly on my mind. Sustainability, that of course just means maintain and be terribly boring, and everything unfolds all in an orderly fashion. Resilience, of course, means recovery, quick recovery from difficult conditions, bounce back and survive longer, as well as adaptation. Thrivability is an interesting one, which says bounce forward, just prosper, thrive, develop vigorously, fine terms, strive for greatness. What it really means is how does one go and share this knowledge? How do you go off and make this happen? One thing that is overlooked in a major way is the geothermal energy which we are sitting on. If you look at the molten iron core of the Earth, it's sitting at 6,000 degrees C, the same temperature as that of the sun. Only this temperature, this energy is rising to the surface constantly everywhere on the planet. This slide just says, hey, it's a little closer. It's only 6,500 kilometers away, whereas the sun is 150 million away. And I, of course, take full advantage of this. Most people, when they think about renewable, think of the sun, and they're missing out on where the real renewable energy is. My hardware, I call it decentralized, efficient, innovative, but I have an electric vehicle, I have a microfit array, 3 Tesla batteries, I have a net metering array, I have a geothermal heat recovery and storage subsystem, ground source heat pump. lots of energy consumption meters, and of course, a lot of AI going on in the software and the control room. Just want to show you a quick look of last year's performance. We talk about coefficient of performance, which is energy production divided by consumption. And you can see how that changes throughout the year. And of course, break even is 1. And it means that we're getting into the realm where in October and transitioning into November, where my production is going to be dropping off as the elevation of the sun is not going as high. The days are getting shorter and we get more cloud coverage. I'm being waved at about time again. But here is an energy profile, and it's showing what's happening with my consumption in blue, the sun, the solar, as well as the battery. Battery charging is below the x-axis, and we also have a grid interface. In this case, I did end up dumping some energy onto the grid, and that was on August the 26th. And I just want to point out, in terms of energy consumption, this is hot water heating. This is our electric vehicle being plugged in. The little bit of fur on top of that is the ground source heat pump coming on to do some heating, or this would be cooling, pardon me. At midday, here's the hot water coming on again, and this bump is me when I turned on my little computer. It's got 9 hard drives and 4 monitors, and it takes a bit of a bump, and energy conservation suggests that I might use my phone. Grid versus microgrid. The electric grid is large, brittle, expensive, vulnerable, aging infrastructure, irresponsible, nuclear and fossil fuels, inefficient, distant, user-dumb, short-term profits, and could lead to stranded assets. It's political meddling going on, and of course, if you have any medical devices, you're under threat of the grid going out all the time. Whereas a microgrid satisfies a demand for affordable, resilient in terms of survival, reliable, and lots of energy options, as well as being user smart and flexible. It generates job, it provides hope, independence, and no fossil fuels at all. The average Canadian household consumes about 35 kilowatt hours of energy every day. My average over the year is about 23 kilowatt hours per day, but that includes all my heating, cooling, my hot water, transportation, and the energy cost is 0. My consumption actually, yesterday, I just put this in this morning, was 23.4 kilowatt hours. Okay, I'm going to turn this over to Jane.
Hi, I'm Jane Wilson. I'm an architect, and I'm the opposite of Art. So he's the scientist, I'm the artist. And when it came to having the opportunity to put proof of concept into my work as working with sustainability as an architect for many years, I wanted, when we built our own home here, I wanted to put that into effect. I also realized that my husband and I are not spring chickens, and complication was not something that we wanted to put into our house. So one of the goals was having a simple house that we could manage, that would be energy efficient, and have low operating costs going forward. So really, when we're looking at designing in the 21st century, we're not doing that well enough. You know, we really have 3 different branches that we have to look at. The first is understanding where we live, understanding the site. What are the potential threats that we have? The second is flexibility. We don't know what's going to happen. We don't know if we're going to break our leg or become infirm in other ways. We don't know if suddenly grandchildren are going to move into our house or whatever. We need to build with some sort of flexibility in mind. And I think it goes without saying, we want to live in as healthy an environment as we can. So the material choice and whatever should be something that's healthy. Our air quality, even if it's not great outside, should be good inside our house. And at the base of this is really making that transformation in our construction industry to really build well. You know, it seems to be, as you look around Ottawa, it's a race to build as fast as you can. And that really shouldn't be the point. We should be building well, and then we don't have to rebuild. And part of the formula is air tightness, insulation, and good material choice, low embodied energy, but also that sustainability, recycling, preaching to the choir here. You know, there are a lot of different materials we can use. So, at taking our house, we moved to Canada just because I like the winters here. But in moving, I wanted to make a house that was sustainable. We're near the Rideau River, so the site elements became very important. We don't have a basement, and we don't hear a sump pump running all the time because of that. But also, when I help people design their houses, you have to think about where the house is. You can't take one house and put it anywhere. You know, I hate lawnmowers, so around, just around the house, we have eco-lawn grass, which requires mowing twice a year. Then we have a wildflower meadow at the back of the house. Work in progress. We will get there. It was a treed lot. We took down as few trees as possible. Our driveway is relatively short, and I'm lazy. If it's we've just had 2 feet of snow, I want the plow to come, plow it off, and I can sort of, you know, go out and put a few shovels right in front of the door and feel like I've embraced the winter without too much work. You know, the trees that we removed were to the south of the house, where we also put the septic bed, so we didn't have to take away very many trees. We still have the roof situated so that we can put solar panels on it. My accountant husband has not yet given me the okay for the expenditure, but we're ready for it, and we will get there. Okay, so this is a house. It's nestled in the woods. I am a tree hugger. You know, the light rail is not coming to my house anytime soon, but I'm going to have to deal with that, and we all have our foibles. Inside the house, in terms of being flexible, you know, really having space that you can move around. So, in open plan, you know, not putting a refrigerator where you're watching Game of Thrones. You know, it really is a good thing. So we have a pantry around the corner that allows food storage and refrigerator. We have a couple of spaces in the house which are open most of the time, allow sort of a free movement, but can be shuttered or just brought. So we're not having doors and closed rooms. We can be flexible with our use and space. Getting light into different parts of the house. As you can see, in the main part of the house, our windows to the south let in lots of light. It's great. But also for those rooms that are a little further behind, you know, we put transparent areas so that light could filter through. So every house is different. How you design it is really on the needs of the group, but keeping the tenets of flexibility and potentiality in mind when you do that. Building correctly, very important. When you start to build, when designing a sustainable house, you really have to think of it truly as a three-dimensional object. And it is very difficult for people to think that way, because normal people think in two dimensions, and to really see what the impact of the thermal insulation around a house, it takes some thought. So it is something, and you really have to diagram it and cut it and slice it and make sure you've covered all the bases. In our house, the idea of taking that care in construction, putting 8 inches of insulation under our slab, it's great. We have a concrete floor, which you can still walk, in socks on in the wintertime. Having the double wall with the good air barrier, making sure, doing the blower door test, making sure everything is well sealed, extremely important. I know that there are homes being built now where they're not doing blower door tests. It's a crime, simply. Having the continuous insulation on the exterior of the house to give it, here we use the Roxol comfort board, which I like because it makes it look like a blanket. And I always think of my house sort of wrapped in this really nice, cozy blanket. Anyway. Okay, for mechanicals, I don't need Art's AI to manage our mechanicals. First of all, we have the sun coming in from the outside, from the south side. Somehow I missed on this diagram, but we have one 2-foot by 2-foot window on the north side. So we balance most of the windows on the south, a little bit on the east and west. We have an HRV to circulate the air, works well. We have 2 mini splits. They're very efficient, and they heat and cool our house for the little that we need it. We also have a wood stove just because I like to see a fire in the winter. It is a passive house wood stove. It draws combustion air from the outside rather than from inside the house. And again, going back to the idea that the inside of your house and the outside of your house are both parts of your house. You really have to look and say, yes, I'm designing inside the house, I'm designing outside, both for people movement and also that feeling of where you are. Once we're part of our, we're in our nature, in our site, we're going to be a lot more comfortable. And that's it.
Sucha?
She's great with those hand motions.
Thank you, Jane, and Art, and you guys are really learned person in this field. Well, for the last couple of years, I've been interfacing with Art, and we are really blessed to have such a resource. And so Art is really motivating us a lot, and he's also regular speaker at the Professional Engineers Sustainability Seminar which we conduct, and I seen his implementation at his home. It's really remarkable. If someone hasn't seen it, it's really worth visiting it. And so I retired after 25 years at Nortel Networks. My passion has always been environmental sustainability, and so I teach at Carleton University a final year course for engineers on energy, energy design and policies, how we can shape our world towards a more balanced place. And Art asked me to expose some of the work being done by students at Carleton, Algonquin College, and Queen's University on building. And so I'll focus on that. If there's a spare time, then I can share with you some of the things we do at the Sustainability Committee to actually evolve better policies, how we can motivate the government leaders and regulators to actually help us to move in that direction. So Carleton University have a very good research facility where they experiment with all kind of technologies, whether it is the ground source heat pump or other insulation furnaces. And so they have a dedicated facility. They are always experimenting with that. And the team of professors and students are involved. And this facility is visible as soon as you go in Carleton University. It's on the right hand side. And so in 2013, Carleton University, Algonquin College, and Queen's University students, this is students project, they built a home, and one of the incentive for them was to actually appear in a global competition which is held in California, and this is spearheaded by the Department of Energy, the U.S. Department of Energy, to actually have a building homes which would minimize the energy and help our way of living. And so this home was constructed by students. There were about 100 students involved from 3 university or colleges, and they presented this paper at the professional engineers chapter here. They actually won award from our chapter. And some of the key things, the home has to be functional, livable, so they can, normal family, it's about 1,000 square feet. And in the competition, actually they did very well. There were 19 global teams entered, from Australia, from Austria, from all over the place. And so they came first in overall engineering. And in engineering, they were, they had to have windows and shading and applications so that they can remotely control the shading and in the summer and winter. And in terms of affordability, so this home needed about $300,000 to construct from a commercial point of view. And it tied for first place in energy. In other words, it was a net zero home. It actually produced more energy than it needed. So 7.5 kilowatt solar energy. And it's a hot water concept. Again, they were using solar and other methods to make sure they have the hot water with minimum energy. And in terms of market appeal, because how people can live and functional home, so that was 4th place. Overall, out of the 19 team, it was placed 6th. And so the home, just under 1,000 square feet, and window shading and energy monitoring and mobile applications, so you can monitor from monitor and control from anywhere. Energy, it uses less than what was produced, and it was for Ottawa's weather. winter and summer. I'm glad you like Ottawa. This is a winter. It's beautiful. And
It's almost here.
yeah, in terms of Jan's desire to move away from the lawnmower, I suggest having lawn goats would be the best combination. And there are people actually using lawn goats. Google and few other places are only using lawn goats. But we need to start working how to train them so they don't damage the flowers
Yeah, that's right.
and
I do enough damage to the flowers.
so in terms of the competition, it was a very balanced engineering and architect work, and the home was shipped from Ottawa to California, and the team reassembled it in 9 days in California. And so it has to be compact and easily assemblable. And let me see. So I saw another home at Carlton as I went there this weekend. So this looks like a mobile home on wheels, and rather than calling it a solar home, I would call it a green home. So that has a green roof, if you are able to see that. And it's like a bachelor apartment, so one room, kitchen. It's very compact and very nice insulation, and windows were all over. So that home was 2013, and actually more technology or more planning went in, and so this competition is taking place every year. And I have given a website here, so if anybody want to look into more detail, then the US website, Solar Decathlon government website, that's the number one. And so the other things we do at the sustainability committee, we try to motivate, bring awareness to the public and to engineers in terms of technology and policies. And we've been feeding some input to the Ontario's municipal affair ministry as well, so how they can start looking and motivating, and they have been very good actually. I remember we asked them in Kannada, we had I live in Kannada. In Kannada we couldn't dry the home outside, and it was banned, and some of the apartment buildings in Ontario, they were not allowed to dry their clothes on the balcony. So we asked them to free people to dry their clothes, whether they live in apartment or home. Actually, government implemented that, so it's now banned. No owner can stop you from using your balcony. And few other things we did. They were actually very receptive. And so one of the things we've been looking at is I have a plug-in car, so I time-wise it get charged during the night time, but the grid and the energy is cheapest at around about midnight. From about 11 o'clock till about 5, hardly anybody using the grid, and they have energy which can be flowing at a much cheaper rate. So it would be even nicer to have off-peak rate, but in addition we should have super off-peak rate when things are really cheap. And so it takes about 60 cents to charge my car. It's a hybrid, so it only needs about 6 kilowatt. But if they put super off-peak, then it may take only 20 cents or something, if we have. Okay. And so one of the things we do is to try to interface with our policymakers to help them to understand and how they can help the environment. So, few things we have seen, like the root cause of our environmental around the globe is really the population explosion. And UK has brought in a law to actually, if you have more than 2 kids, then you don't get any tax write-off or family benefit. You pay for any more than 2 kids since April 2017. And so that's something very, very positive thing that we can start thinking. The other thing is, if we can have our leaders giving us a good example, for instance, our MPs traveling economy class versus business, that will cut down the footprint by 50%. And that can be propagated downward, all level of government, even all the government employees, And there are people in our government even today, some minister, they only use economy class, they refuse. And I was in a meeting with the European Union ambassador. His whole travel is economy class to actually cut down the taxpayers' wastage and the footprint. And so, as David led, that you guys are all ambassador, have good contact. Maybe you can motivate your candidate to look into those things. And I think David Common of CBC, I've been watching his marketplace. He done a remarkable work in cooperation with the Malaysian government and Philippines government to train educate our Minister of Environment that how damaging Canada is playing as an example. So hopefully it's having better effect on our Environment Minister to actually make some better move. And so it looks like my time is so I won't take more. Thank you very much. It's a really pleasure to see you guys. So much devotion you guys do to the well-being of our society. Thank you.
Okay, we're going to go into question period, and I'm going to leave the last slide up so you help remember the names of the people. And Madeline, how do you want to handle this?
I think